Hi everyone, we're roygbivision. I'm Anne.
I'm Renee.
I'm Ethan.
And I'm Jyoti. So to get started, our goal for our project focused on two specific problems that rise because we have a broad spectrum of colors that exist in our world and that we use. So the first part, we're looking to create a color detector that labels colors found through the camera and onto the screen. So what this looks like is that our detector will outline multiple targets, whether it be a person, object, animal, anything else, and then output the dominant color that's being identified. For our second part, we're going to input a photo and a palette size, and it'll return the closest colors in our data set to output color names and hex values to produce a aesthetically pleasing color palette.
Okay, so going into more detail about the color detector, we use OpenCV so that we're able to utilize the webcam on our laptop. And we basically get the RGB values that are getting outputted from the video capture and we convert them to HSV. And this way we can define color ranges for a basic color, which means basically we're getting a really, really light blue color, for example, and a really dark blue, and classifying it as just a general blue. We also use the technique of using masking, color masking, and also the contours so that we're able to identify the actual outline of the object and not get it like blended in with other objects. Some issues that we ran into were it was detecting the wrong colors for a couple of the colors because it seemed that the ranges were overlapping. So for example, if there was like an aqua colored object, it would say it was blue and green. And so to fix this, we went through the HSV color picker and just kind of played around with different ranges of like dark and light colors to make sure we had the right range for us. As well as lighting also, we didn't have much control over. So we kind of just like let that be. Another issue was that OpenCV wanted the color ranges in HSV, and we didn't realize that H actually has a max of 179 versus SNV having the max be 255, as well as it sometimes took the RGB as parameters in the order of BGR, which kind of tripped us up. But now we'll just go through a demo. Okay, so starting with this demo, as you can see, kind of every object in the webcam's like area is detected as a color. And also like I said before about the lighting, it kind of gets different colors. Right now it thinks my face is pink, but we're gonna use a Rubik's Cube to get more of like a specific color. So as you can see, it kind of gets the center of the object and displays text in white. So it has all of the basic colors like green, white, it has pink, and on this Rubik's Cube, I think it actually is pink. We also have orange, but as you can see, there's a little bit of red because as I like bring it closer, the lighting kind of changes it. But then it also has blue. But yeah, it gets objects like that. It also gets like weirdly shaped objects like this one. It can properly display it as pink. But yeah, that is the demo of our first part of our project.
Okay, so the second part of our project was our color palette, and we did this by first doing k-means clustering on an image to get the top k colors in the image. And then we found matches for those colors with colors in our data set. This data set had like 800 colors with corresponding RGB values and then like color names and hex codes. So we found matches by finding like a minimum square error between our like target color RGB values and then like RGB values in our data set to get the closest color or colors for our palette. Initially, we tried making a neural network for this, but then we realized that because each color in our data set is unique, like there wasn't really a way for us to evaluate performance. And the minimum square error seems to get like pretty accurate results anyway, so we just stuck with that. And then while debugging, another issue we had was that OpenCV wanted the NumPy arrays of our image data in 32-bit floats for the k-means clustering instead of what we had before. So we had to convert that. So to demo the second part of our project, we basically just ran this code where we have a cherry blossom picture, and then we did palettes of size 2, 6, and 15. So our original picture looks like this. And then when we found a palette with two colors, this is what it looked like. And then with 6 colors, it looks like this. And then finally with 15 colors, it looks like this. And there are a couple more examples as well on our website.
Regarding next steps of the project, we would focus on improving the color detector's ability to correctly recognize the outlines of different objects in the video capture. If we were able to improve the detector's object detection, then we would possibly be able to support a larger project, such as improving the accessibility features of screen readers. And another thing that we could do with this project is create a web application for palette generation, where users would be able to upload a photo and get a corresponding color palette back. Thank you for listening to our presentation. We hope that you enjoyed it. And here are some of our references.